in part A, we have no calculators allowed. So we will try and solve this to the best of our abilities. All right, so question number 1. Right, so we have this function. We want to find the derivative of it, right? So if you're going to find the derivative of this function, write y, rewrite y, x, 2x plus 5 to the power half. Now use, you can try solving this. You have dy dx or y prime.
It will become like we're using
1
the product.
and
Yeah.
product
Okay.
and chain. Differentiate x, you get 1. Leave the 2x plus
1,
5
yeah.
to the power half
1 over 2.
plus derivative of the
Plus,
second part, 1 over 2, 2x plus 5 to the power negative
negative
half
1 over 2. Yeah. Times x.
times the derivative of the inside. Why didn't you differentiate the
derivative
inside?
of the inside, yeah. So to
Times
become like
2,
just
and then
2.
leave the x. Right, so what we have here is the square root of 2x plus 5 plus x over the square root of 2x plus 5, because that's to the power negative. Right, so if that is to the power negative,
answer is
okay,
3x plus 5. Common factor, answer is a, just, yeah. We're multiplying by root of 2x plus 5. The root cancels out, so 2x plus 5 plus x.
Yes, yeah, so you're multiplying the first part, so your LCD, your lowest common denominator is the square root of 2x plus 5. This part has no denominator, so you're going to multiply this by the square root of 2x plus 5, so you get 2x plus 5 plus x, so 3x plus 5. Answer is A. Good. Let's look at the next one. This is basic integral. You need to remember your rules. Integral of a to the power x dx. Remember, a cannot be equal to 0. So what you have is a to the power x over ln a plus c. So what's your answer here?
C1.
Yeah, your answer is C. Remember, integral of e to the power x dx is the same thing as saying e to the power x over ln e plus c, but ln e is 1, right? So that can apply to all a to the power x functions, exponential functions. Next one, we want to find the limit as x approaches -7 of this. Now, limit as x approaches -7 into an absolute value is a problem, because we're going to say absolute value of x plus 7. We need to redefine it, right? So if you redefine this absolute value, you will get x plus 7 if x plus 7 is greater than or equal to 0, negative into x plus 7 if x plus 7 is less than 0. So this will become x plus 7 if x is greater than or equal to -7, negative into x plus 7 if x is less than -7, taking that over. We just solved it. Now we got a problem because it's at -7, so you got limit from the left, you got limit from the right, and you got limit from the left. Okay, so you have to do two limits. Left hand side limit will be 7 from the left, -7 from the left. So this is how you write it out. The limit on the left hand side is equal to limit as x approaches -7 from the left, x plus 7. If you're taking -7 from the left, it's going to be x is less than -7. You take the bottom function, which is negative into x plus 7. Those cancel out, we get -1. And if you take the right hand side limit as x approaches 7 from the right, -7 from the right, you get x plus 7 over what's 7 from the right. -7 from the right is the top function, which is x plus 7. Those two cancel out, you get 1. So -1 is not equal to 1, so it's non-existent. Are we good? And see, look at the types of answer. Look at the types of answers they gave us. They gave us an answer which is -1 and 1, and they gave us. So you see, you can get confused. So remember, whenever you have an absolute value function, you have to redefine the absolute value and then solve. Most of the time with the absolute value function in limit problems, if it's at that point, if they said -7 to the positive, to the power positive, then it will be, the answer will be 1. If you set to the power negative, then the answer will be -1. Okay, great. Let's solve this integral. This integral here is, remember, this is to the power 5, so we'll make that u. Try to use u substitution here. So let u equal to x to the power 1/3 minus 4. So du is equal to 1/3 x to the power -2/3 dx. So let's rewrite this. Du is equal to 1/3 x to the power 2/3 dx. Do we have 1/x to the power 2/3 dx in our integral? Yes, we do. Call this the integral. So that an integral now will now become, do we have, what is this? This is u to the power 5. Problem solved. Right, now we need to look at this now. Look at the, leave the 6 as it is. Take the 6 out of the integral. So we'll take out the 6 out of the integrals, which is 1/6, because that's in the denominator. That's u to the power 5. So what's in the denominator? What is 1/x to the power 2/3 dx? 1/x to the power 2/3 dx. We're only solving for this
5.
part.
It will become
No,
the power
it's 3
5.
du. It will become 3 du.
Oh, yeah, just 3 du.
Yeah, because I'm trying to solve for this. I'm trying to solve for 1/x to the power 2/3 dx. There's it here. So take the 3 across, 3 du. Now 3/6 is half. That's u to the power 6/6 plus c. We just integrated this, plus c. So we're getting 1/12. What is u? X to the power 1/3 minus 4 to the power 6 plus c. Where's the answer? Over 12, right? Is answer A?
Yes.
Okay, let's move on to the next one. Okay, we did this in, I remember this, we did it in AB. Anyways, we have a table of values. We have R of t. We want to use a right Riemann sum with 3 subintervals. So right Riemann sum is, remember that this is the width, right? So the width is 5, 5, 5. So delta x is just 5, right? The width of the interval, and these are the heights. So because we are using right Riemann sums, we leave out the first value. So we're going to take 5 times this, 5 times this, and that times that. Okay. So the area is equal to, we are using area of the right Riemann sum. Okay. So the right Riemann sum is the width times the function value. Okay. Width times height. So what's the width? Width is constant each time. 5 minus 0, 10 minus 5, 15 minus 10. So the width is constant. So just take out 5 as a common factor. We're left with a 100 plus 75 plus 55. So we got 100 and what is this?
280. Oh, wait.
Let's work it out properly. That's 5. That's 175 and 55. There's 0 there. Carry 1. 8 and 5 is 13. 230. Okay. Now half of 230 is, half of 230 is 115 and multiply by 2, 1150. Okay. I'm doing this multiplying by 2 over 2. Okay. So 5 times 2 is 10. I took half of 230. Okay, which is 115, and then add a 0 because 5 times 2 is 10. Okay, just quick multiplication techniques. Easy. This one here, what is the sum of the series? If you want to find the sum of the series, it's an infinite series. So we try to look for a geometric pattern. Let's check if it is geometric. The pi is remaining constant. So if you take term 2 divided by term 1, what's term 2? Negative pi over e squared divided by pi over e. So you're getting negative pi over e squared multiplied by e over pi. The pi's cancel out. You're getting negative 1 over e as a common ratio. So your first term is pi over e.
Pi
So
over
we
e.
got sum to infinity. The first term is pi over e.
1
And
minus
we divide 1 minus 1 plus
1
1
over
over
e.
e, because minus minus.
Yeah.
Okay. Right. So we got pi over e divided by that's 1 over 1. So it'd be e plus 1 over e pi over e multiplied by e over e plus 1. E's cancel out, you're getting pi over e plus 1. Pi over e plus 1. The answer is B. Are we good?
Yes.
Right. Let's look at question 7. If f of x is equal to x squared plus 1 to the power 3, what is f of limit as x approaches negative 1 of f of x? Now it's important. We got a point. This is more like average gradient, right? So it's more like, because we're pushing limit as x approaches negative 1 inside the function, we're trying to find the instantaneous gradient at negative 1, right? Remember what f prime x formula is. Limit as x approaches h of f of x plus h minus f of x divided by x plus h minus x, that value minus that value. So that's the reason why the x's cancel out. So what do you think the denominator is going towards? 0, because if I push in, sorry, h approaches 0, not x approaches. Isn't the denominator 0? And what's the numerator? 0.
Yes.
So you're getting 0 over 0. Same situation here. Negative 1, f of negative 1 minus f of negative 1 over negative 1 plus 1 is the same thing. X minus minus 1 is x plus 1. And the denominator is going to 0. So basically you're finding f prime negative 1. Right. So first let's find f prime x. F prime x is 3. Come on, chain rule. Into x squared plus 1 squared times the derivative of the
times
inside.
2x.
Right. So now let's find f prime negative 1. If you substitute negative 1 inside, that's going to be 2 squared times negative 4. Negative 16, we get negative 48. Are we good? No, we don't have negative 48. Sorry.
Negative 2,
Let's see.
not negative 4, negative 2.
No,
No, this
we
negative
squared
40.
this. We squared this.
No, 2 times 2x, it will become times
Oh yeah,
negative 2,
negative.
not negative 4.
Negative. Thank you. Negative 4. So that's
So negative 24.
negative 24. Excellent. The answer is A. Very good. Let's continue. I think we did this in AB as well. This is the double prime function. It's a quadratic, so it's like positive x squared, right? If we integrate this, we're going to get positive x cubed over 3. If we integrate this, we're going to get positive x to the power 4 over 4. But don't do it like that. Let's just try to see.
Concavity.
Yeah, this is already, yes, we need to check the concavity. So let's just say this value is from 1 to negative 1. So from negative 1 to maybe this point over here. So let's just assume some points here, right? So maybe negative 0.75, right? So where is it concave up? From negative 1 to negative 0.7, and from 0.7 to 1, it is concave up. So it's up like this and it's up like that. And between negative 0.7 and 0.7 is down. And the inflection points are at those points. So let's see where it is concave up. It can't be a cubic function, right? That's eliminated. It's definitely x to the power 4 function. So cubic functions are eliminated. So the answer is between C and D. So it's concave up. Good. The answer is D, because it's concave up to that point. See, this is concave up. Right?
Mr. Ghazali,
Yes.
can you go up for a second?
1 second, and it's concave down in between there. Yeah.
You said negative 1 to 0.7 is concave up. Are you talking about the graph of f double prime or?
No.
integrating?
No. I'm talking for the graph of f double prime. I'm talking about the graph of f. What does f double prime gives you? The positives and the negatives. Okay.
No, but
So
the whole thing is it's a quadratic function, so it's always concave up.
okay. So No. You're not looking at, you're looking at the graph of f. You're analyzing the graph of f. Remember, f double prime x greater than 0, that gives us concave up for the function. And f double prime x less than 0, that gives us concave down for the function. Concave down for f
I see.
or f, right? We're looking at the original function.
Yeah, so if
So
it's
the
if we
the
integrate it
positives,
twice,
yeah,
what'd you say?
you don't need to integrate. You need to look at the graphical solution. Okay.
Yeah, I know.
Right. Great. So that's your answer there, which is option D. Let y equals to f of x be a differentiable function such that dy dx is equal to x over 8. F of 8 is equal to 2. What is approximation of f of 8.1 using the tangent line approximation? Right. So what we need to find, remember, f prime x, that's the slope. Okay. What's the equation? Y minus y1 equals f equals m into x minus x1. So y minus, what is y? Y is f of x, right? Y is f of x minus y1 is the given condition, like f of x naught is given at x is equal to 8, right? So we need to find f of 8 is equal to m. M is a derivative evaluated at 8. And what is the value of x? We don't know, but we know what the initial value is. X1 is 8. Remember, this coordinate, oh yes, this is just a coordinate, man. We can just put down 2 here, right? This is 2. And x1 is 8. Now remember what we are finding. We're finding f of 8.1. F of 8.1 is approximately equal to, take the 2 over, so 2 plus, what's f prime 8? F prime 8, the derivative at 8. Now remember, we given this point here, what is the coordinate? The coordinate here is 8 and 2. So if you put 8 over 2, x value, y value, you will get the slope. So we get 4. And what is 8? What is the value of x? 8.1. 8.1 minus 8. So you're getting 2 plus 4 times 0.1. So that's 0.4, 2.4. Yes. The series 1 minus x squared plus x to the power 4 over 2 factorial, x to the power 6 over 3 factorial, x to the power 8 over 4 factorial, and so on, converges to which of the following? Now, it's very
Is the
important to
cosine
remember.
function, sir?
No, wait 1 second. We need to check.
It's alternated.
We need to check. So e to the power x function, you got to remember the basics. E to the power x function is x equals 0, n equals 0 to infinity. X to the power n over n factorial, that's e to the power x function. So the e to the power x function goes like this. We need to expand it and everything and check, right? E to the power x function goes like this: 1 plus x squared over 2 factorial plus x to the power 3 over 3 factorial plus dot dot dot. The cosine x function is n equals 0 to infinity, negative 1 to the power n, x to the power even over even factorial. So if you're going to start with this, you're going to start with 1 plus, no, 1 minus x squared over 2 factorial. You're substituting 0, so that's 1. Yeah, all that is good. Plus x to the power 4 over 4 factorial minus x to the power 6 over 6 factorial plus dot dot dot. So it's not matching up, so it can't be cosine. And what's the sine function? You got to remember all this, huh? N equals 0 to infinity, negative 1 to the power n, x to the power odd 2n plus 1 over 2n plus 1 factorial. And that is 1, no, not 1, can't be 1. Starting with n equals 0, it's going to start with x.
Yeah, is x here. Minus
X
again.
minus x to the power 3 over 3 factorial plus x to the power 5 over 5 factorial minus x to the power 7 over 7 factorial plus dot dot dot. So obviously it can't be
So,
sine function. It can't be cosine function. Wait. We need to check now. It can't be cosine function because the powers are not matching up. No, we confuse between cosine and e to the power x function. So let's substitute into e to the power x function. Now in the e to the power x function, if I substitute e to the power negative x squared, so x becomes negative x squared, all right? Yeah, we need to check because the answer, what do you mean the answer is? We don't know whether the answer is A or B or C or D. We're checking.
no,
Just
but
substitute
you
e
were
to the
checking,
power
so it's
negative
like by
x
order
squared.
of elimination, it was A.
No, one second. Let's check this. N equals 0 to infinity. Okay, and we got x gets replaced with negative x squared to the power n over n factorial. So this is the same thing as saying, if I'm trying to check for, this is the same thing as saying sigma negative 1 to the power n x to the power 2n over n factorial, n equals 0 to infinity. Now remember, this is like your an formula, okay? Now if you tried your an formula and try to fit it there, do we have an an formula? Yes, we do. We good?
So,
I got an
so
answer of D.
with questions that ask about series, do you think it's better if I memorize just everything and then when it comes to the test, just write down every rule?
Or you wanted to go from the beginning. You wanted to
Oh, I
solve
see what you
from
mean.
A,
Yeah.
B, C. You wanted to do elimination here.
No. I was just like gonna check every single like rule of sine x, cosine x, and e to the x of
Okay.
the series.
Okay, let's try it out, because the first one is saying cosine x squared plus sine x squared. So you're just gonna replace the x squared here, right? And obviously you are kind of like adding even and odd powers here, right? So
Oh
because
yeah.
you replace, so I don't think that will work out, and you won't get a 1 because, no, you should get a 1. But now because you're adding 1, okay, cosine will give you a 1 first. And the sine, if you replace the x with the x squared, you're going to have 1 plus x squared. Do we have 1 plus x squared? No, we got 1 minus x squared. So option A is out.
What does B give you?
Right, let's check. X times sine x. So you're going to take x times the sine x. So sine x is here, right? B is x times sine x. So if I multiply this by x, I will get x squared. And if I multiply this by x, you have to check the fourth term as well. I'm going to get x to the power 4 over 3 factorial. But now I've got x to the power 4, and I'm going to take 1 minus, just take the first two terms. You don't need to take all the terms. So it's 1 minus x sine x. So I'm going to take 1 and subtract x squared. I got 1 minus x squared. Then I'm going to subtract. So plus x to the power 4 over 3 factorial. I don't have x to the power 4 over 3 factorial. I got x to the
I
power
see what
4 over 2 factorial, so that's out. Now try cos x. Obviously, this
we
is
just tried.
clearly not cos x. Yeah, because it's 1 minus x squared over 2 factorial. The even powers and the even factorials match up in each terms, right? So definitely not cos x. Okay, so we stuck with this. Are we good? Right,
Yeah.
excellent, guys. Integral of x cos 2x dx, we're going to use the DI method, differentiate something and integrate something. We'll always differentiate the polynomial functions, which is x. Start with x. What's the derivative of x? 1. What's the derivative of 1? 0. Now, next one is cos 2x. What's the integral of cos 2x? Sine 2x over 2. Derivative of sine is
Negative.
cos.
Oh no, positive. Yeah, positive. Will be positive.
Yeah. Then the integral of this is
Negative
cos
cosine 2x over 4.
over 4. Now remember plus minus plus, right? So you don't need to do another one because there's 0 times. So this is plus minus. So what's your answer? X times sine 2x over 2. So my answer, the integral answer, is now equal to x sine 2x over 2. 1 times negative this is negative cos 2x over 4. Which one is it?
C1.
half x sine 2x minus quarter cos 2x. Yeah, answer C.
Yeah.
Right, excellent, guys. Next question. Question 12.
No, so isn't 1
second.
times negative cosine 2x over 4?
Yeah, it's a negative. Wait, we messed up.
Yeah, but with the negative, it's plus,
Plus
so it would be
C.
D.
Oh, yeah, so negative and negative is D. Yes, correct. Thank you, because
Oh.
remember, 1 times negative. Yeah, it's negative. Yeah, you're right. So, whoa, look at the confusion there. Oof. But look here, guys. You could have used the formula integration by parts. Integral of u dv equals
Yeah, it's better.
UV.
Yeah, it's also easy.
integral of v
UV.
du. It's
Yeah.
use this. You can make u equal to something that you can differentiate and make v equal to something that you can integrate, which is the second part.
So we can use this for anything. Integration by parts.
Yeah, but avoid it. For these types of functions. It's better to do this, man. Leave out integration
For
by
the
parts.
polynomial, the I method is better. Yeah. Okay,
Yeah.
let's move on.
Let's look at, given that 3x minus tan y is equal to 4, what is dy dx in terms of y? Now remember, whenever you have a function like this, it's always implicit differentiation. Y is a function in x, y is y of x. So if I tell you to find, just remember y is a function in x. So you need to do implicit, in other words, chain rule, whenever you find the function y. So derivative of 3x, we're finding the derivative. What's the derivative of 3x? 3. What's the derivative of tan y?
Oh, I forgot.
6 sec 10. 6 sec 10. 6 sec 10. Remember the table. So sec squared y times that. What's the derivative of y now? Y prime.
Y prime
is equal to 0. So what's y prime equal to? Take the 3 over, becomes a negative 3 over negative sec squared y.
which is positive.
And what is, yeah, so positive. What is 1 over sec? Cos.
3 cosine square. So
Answer is B.
Nice.
Right, great. Thanks. Next question. Which of the following is the solution to the logistic differential equation? Logistic differential equation has something called a carrying capacity, right? Which is 500.
Yes.
Right? That's a carrying capacity. The inflection point of this is basically 500 divided by 2. Just remember that that's 250. Capacity, right? That's a carrying capacity.
Or maximum gross, yeah, in this case.
No, wait. Now they told us, now remember, carrying capacity is where the graph can reach a maximum. It will start to decay, it's like start to go towards that line. Now this is dy dt. Remember, y naught is 100. So this is a graph of y of x, right? This is the original function. So y naught is equal to 100. Basically, you starting initial point. This is a y-intercept, right? The y-intercept is 100. So now remember what I said, carrying capacity has this broken line. So your logistic equation there's your carrying capacity here. Your logistic equation goes like this, or it can go like this, right? So it can't be this. These are not logistic equations. So it can either be B or D because of the carrying capacity. But the carrying capacity is 500. It's not 100. And the initial value was y-intercept of 100. So the only one that matches there and there. Are we good?
Yeah, so D.
Yeah, so the answer is D. Remember, your graph can either be like this or like this. Okay, this is a decay and this is a growth, exponential growth. There's a decay in the logistic equation. Anyways, right. What is the absolute minimum of y equals negative cos x plus 10? Now, because they're asking for the absolute minimum, let's check the endpoints first, right? So what's y of 0? Observe the y values. If you substitute 0, what is cos of 0? Yeah, so that answer is -1. What's y of pi by 2?
-1.
Remember now,
Again.
-1 again. So which means that we don't know whether this is the absolute minimum. So let's check the derivative and make it equal to 0. If you find the derivative here, derivative of negative cos x is sine x.
It's negative sign.
What's the derivative?
Oh, positive sign, yeah. Positive sign.
Yeah. So I'm going to put negative sine x, all right? And the derivative of sine x is cos x.
It's negative cosine. Nice. Just cosine is negative, yes.
Yeah, there's a negative here. So the derivative of sine is just cos, right? Now we have an equation to solve. We get sine x equals cos x. we can divide both sides by cos and make it into a tan equation, right? So tan x is equal to 1. When is tan of x equals to 1? When
45
x
degree
is equal to
or
pi by 4.
pi over 4.
Now, yeah, so now let's substitute y of pi by 4. Substitute into this original equation. Y of pi by 4. This is negative.
Root
What's
2 over 2,
negative?
negative root 2
Root 2
over
over
2.
2.
Yeah.
Yes, yeah,
And
negative
negative
2 over
root.
2.
So it's just negative 2 root 2 over 2. So just negative root 2. So which one is the absolute minimum from all of them here?
So
Is it
C.
negative root 2? And yeah, perfect.
Nice.
Let's look at the next question. We did this in AB. The graph G prime is the first derivative of the function G consisting of semicircle of radius 2 and 2 line segments as shown in the figure above. G of 0 is 1. What is C? Okay. What is the value of C? Now, how are we going to solve that? They told us G of 0 equals 1, which means that that's the initial value, right? So we're integrating from G of 3, right? So we're going to integrate from there to there, right? We're going to try to find the area of this one. Now, when you're integrating from 0 to 3, G of 3 is basically equals to G of 3 minus G of 0 is equal to what?
The integral A to B.
0 to 3
Oh, sorry, 0
G
to 3.
prime.
G prime.
G prime x dx. So you're going to move the G of 0 across. So G of 3 is now equal to G of 0 plus. But 0 to 3 we can't really find on this derivative graph, integrating area under this derivative graph. So we need to integrate from 0 to 2.
And from 2 to
Right.
3.
And from 2 to 3. All right, I'm not going to write the rest. You know what to write there. G prime x dx. G of 0
Yeah,
is
it's
what?
fine.
G of 0 is 1.
It's 1.
0 to 2 is pi r squared divided by 4. Where the radius is what?
Then
What's the
half base
radius?
times height.
Radius is 2 plus half base times height. Base is 1. Height is, what's the height? 2. Right, so that's 1 plus, you see 2 squared is 4. 4 over 4 cancel out. So 1 plus pi plus another 1.
That's it.
So 2 plus pi.
No,
2
no,
plus
sir.
pi?
There's no 1.
There's a 1 at the end.
It's 2. Yeah,
Yeah.
it's 1. Yeah, sorry. 2 plus
So
1.
2 plus pi. 2 plus pi, the
plus
answer is
pi.
B there. Let's move on. Right, so we want to find the integral of this. So remember, partial fractions, we need to write this
Partial
in the
fractions,
form
yeah.
of, yeah, so 1 plus 3x over, it's already factorized. So 1 minus x into 3x minus 5.
So
A over
is
A
1
equal to-
minus
over
x,
1
B over
minus
3x
x,
minus 5.
and B over 3x minus 5. Nice.
Easy. So we can say 1 plus 3x is identical to a into 3x minus
3x minus
5,
3x minus 5, yeah.
1
And
minus
when
x.
x is equal to 1,
If x is equal to 1, we can solve for a good, which is 4. A is equal to 4.
and negative 2.
No.
Yeah, negative 2, sir.
Yeah.
3 minus 5. 3 minus 5, negative 2, so negative
One
It's 4
second.
divided by
yes.
3. If
3
x is
minus
equal to 1,
5.
this is. Oh, yeah. Sorry. Thank you. Negative 2a. Yes. You're right. Negative
So A will
2a.
equal to the negative 2 just.
Yeah, there's negative 2a. So this implies a is equal to negative 2. Very good. And if x is equal to 5/3, so a falls out. Man, why are we substituting 5/3? Let's substitute any other
0,
value.
just 0. Yeah, just
Yeah,
0.
let's
We know
substitute
value
0.
of A.
Yeah. Yeah, substitute 0. So we're getting
1
1
equal to?
equals minus 5a plus b.
And plus B.
And a
Yes.
is already negative 2. So
10.
that will give us
So
10.
negative 1/5.
Negative 9.
No. No, take the 10
Serious?
over. Negative 9. Negative 9.
Yeah, negative
Oh,
9.
yeah.
One second. Let's just double check. We substituted 0. So this is 1. That's negative 5a. This is 0. So b times 1 is b. A value is negative 2. We put it here. Negative 5 times negative 2 is 10. Take the 10 over negative 9. So the value of b is negative 9, which is correct.
Nice.
Now we're just integrating this now. So the integral now becomes, what's the integral of a over, so the integral of this is just ln 1 minus x, a
Yeah.
ln absolute value 1 minus x plus
And then
b ln
3x minus 5.
3x
Teacher, don't forget
minus 5.
negative on the A. Negative on the A. Negative on the A. Yeah, isn't it? Yes, it should be negative on the A and negative on the B. Because we find
Yeah, we're
that
coming
B
there.
is -9 and A
I
is
didn't
-2.
substitute.
Don't forget.
Correct. I'm just integrating this only. I'm not substituting a and b values as yet. I will substitute it at the end.
Oh, okay, my
Okay.
bad, yeah.
So remember, integral of ln, I think I told you this, integral of 1 over mx plus c, mx plus c
Ln
dx,
mx plus c.
ln absolute value, you're missing something here, plus c, ln mx plus c over m. There's an over m. Let's make it mx plus k. Plus, okay, so you're missing something as well, times 1 over 3,
Huh?
right? Yeah.
1 over 3, yeah.
You want me to show you how?
Yeah, 1
You
over
can
3.
use you. I can show you a u substitution. See, integral of 1 over mx plus k dx. Let u equal to mx plus k. So what's du equals to m dx, correct?
Yeah.
Right, so that's integral. This integral will now become integral of 1 over u. What is dx?
M.
dx is du over m.
du, yeah.
1 over
du.
M. 1 over
So
M.
1 over m. So
And then you divide again. Okay.
yeah, ln absolute value u plus c. So sort out your u here. So you understand? That's the reason why I multiply by 1 over 3. So what's the value of a? The value of a was -2.
-2.
So the answer can be
So
either C or D. Hold on. What's the value of B? -9 times 1/3.
divided by 3 will be -3.
Yeah, so the answer can only be C.
Exactly.
Right, so no need to go substitute your A and B values and stuff and sort that out.
Interesting. Okay.
Wait 1 second, let's just double check. 1 minus x. Is that correct?
Yeah, that's correct.
I'm pretty sure it's correct.
-2 ln 1 minus x minus 3 into 3x minus 5 plus c. We broke down the A
It
and
was
the
9
B.
divided by 3, yeah.
It was -9 divided by 3. It was -9.
Yeah, sorry, -9 divided by 3, so -3.
What was the value of A?
-2.
-2, yes. So it's be
It's correct.
negative here. It'll be negative here.
It's the value of B, so the second one. The value A is in the left. On the left, -2.
Yeah. So I've got it right. We have it right here. So integrated this, integral of this over. Be careful, guys. You see, you got 1 minus x here. Why didn't I do that? So it's times. It's also a slope here. Times 1 over -1. You know, like how we did 1 over 3.
Oh,
Yeah.
so it's 2.
Because you're gonna. Yes.
Wait, no,
So
no.
it's 2. Yeah. It's 2. It's correct.
Oh, yeah.
Because you got a slope here. So I was just confused between this and this. Why did they put a 2 there? Because we know this is correct because I did this. Yeah, we forgot about the slope there. Be careful, guys. Tricky. See how all the answers are, man. So similar. If you're confused, try to
What do you mean
differentiate
by
the
slope?
function.
Wait a second. What do you mean by slope?
What I mean? Yeah, this is a
Yeah.
rule. This is a rule. Yeah, the slope. You need to multiply by 1 over m. Divide by -1 now. The slope is -1 here. Look at this linear function. Why did you multiply by 1 over 3?
Oh.
Yeah.
Okay, I got you. Yeah.
Right. Excellent.
How tricky is that? Yeah.
Very tricky. Right. A spherical snowball is melting in such a way that it maintains its shape. The snowball is decreasing its volume at a constant rate of 8 cubic centimeters per hour At what rate in centimeters per hour is the radius of the snowball decreasing at the instant when the radius is 10? This is at the end. At what rate in centimeters per hour is the radius of the snowball decreasing? So we're talking about this radius of the snowball decreasing when the radius is set. The volume of the sphere is given by, so it's easy, dv dt. Remember, r is a function in time, so you got to do implicit. So dv dt is equal to 3 times 4/3 is just 4 pi r squared. I multiplied the 3 by 4/3 pi, 3 cancel out, you got 4 pi r squared. And what you're going to do, differentiate r, because r is a function in time.
Times r prime.
Time,
Yeah.
dr dt. Now substitute everything and you're done. What's dv dt? That's what you need to find. No, you need to find the snowball is decreasing in volume at a constant rate of 8 cubic meters per hour. So -8, 4 pi. What's r? R is 10 centimeters. So that's 10 squared. What's dr dt?
Times r prime.
That's what you need to find. You need to find r
So
prime.
what's r prime in this case?
R prime is dr dt.
Yeah, but what's radius prime? That doesn't make sense.
That's what you need to solve.
No, I understand, but like, what is it actually?
Okay. You see, you have a snowball, right? And the volume is decreasing. So obviously the radius will keep on getting smaller and smaller according to time. Maybe it's just melting in the sun.
Oh, the rate of decreasing the radius.
Yes.
Okay, I see.
So obviously if the volume is decreasing, the radius will also decrease.
Yeah.
Wait. Is the radius of the snowball decreasing at the instant when the radius is 10 centimeters? So they're only talking about decrease, yes. So it's -8 over 4 pi times 100. Okay, so 8 and the 4 cancels out. 2 times, and 2 and the 100 cancels out. 50. So you're going to have 1 r of 50 pi. That's r, and that's negative. Negative means decrease, dr dt. So dr dt is decreasing at this rate. So because they said snowball decreasing is already negative, so you only want this part of the answer. Okay.
So the magnitude only.
From where did our 2 come? Again, sorry.
What is that? What's that?
-8 over -8 times 2 divided by 4 pi times 100. From where you take 2? Yeah, this one.
8 divided by 8 divided by 4. 8 divided by 4 is 2.
Okay.
And then 2 divided by 100 is 1 out of 50. 2 over 100 is 1 out of 50. Right. So the answer is
okay.
Right, great. Let's move on to the next question. If the integral from this to this fundamental theorem of calculus, you can find the f prime. Remember to substitute x cubed inside t and then differentiate x cubed. So f prime x is now equal to cos x cubed squared. I replace the t with x cubed. And now I need to differentiate x cubed, which is 3x squared. And that's your derivative. So what is f prime root pi? So f prime root pi will be put the 2 inside and put the 3 outside. Trick. What's the value of x? Root pi. Put the 2 inside and put the 3 outside. I'll tell you why, because root pi, that will cancel out. And 3 times root pi squared. Are we good? So what we have is cos
pi, just pi in that case will be.
No, cos of pi cubed, like this.
Pi cube, yeah, just pi cube, yeah.
Times 3 times pi. 3 pi cos pi cubed. Yeah, d. Are we good? Make sense?
Yeah.
Move on. Yeah, this straightforward, man. Just differentiation. What is the slope of that line tangent to the polar curve? Remember, you have to find the slope of the tangent line to this polar curve here. We don't care what the polar curve is. We want to find the slope of the tangent line. Now, slope of the tangent line is, what is slope of line? Is dy dx. Now we got a problem because r is a function in theta. There. Now, x is equal to r cos theta. Remember, r is a function in theta, and y
R
is a
sine.
function in r sine theta. Now, remember, r is still a function in theta. See this r here. So you need to do. So what is dy dx? Dy dx is dy d theta divided by dx d theta. What's dy d theta? So r prime sine theta plus derivative of sine theta is cos theta times r divided by what's dx d theta? R prime
R prime cosine theta minus r
cosine
sine theta.
theta r sine theta. Now we evaluating this whole thing when theta equals pi. Now I want you to look at the sine graph. The sine graph when theta equals pi is just 0. So all of this falls out wherever there is a sine, because sine of pi is 0. Now I want you to look at cos of pi
-1.
is negative. Very good, -1. So cos of pi is -1 times r. What's r evaluated at pi? When theta is pi. What is r evaluated at pi? You need to substitute inside here. So 2
So-
times.
2 pi squared.
Yeah, so 2 times pi squared divided by, what's r prime? We forgot to find r prime here, which is dr d theta. R prime is 4
4 theta.
theta.
So 4 pi.
Yeah, so what's r prime? So that'll be 4 pi. And what's cos of theta? -1 again?
-1.
Yeah.
So what's
So
the
it become
answer?
like positive pi over 2.
Is it pi
Which is
over
B.
2?
Yeah, it's pi over
Yeah.
2. Yeah.
Hello?
Yeah, it's B.
The 2 and the 4 cancel. 2 times pi. Pi over 2. Nice. Great, guys. Good stuff. Question 19. Question 20. Let g be twice differentiable increasing function t. If g of 0 is 20, g of 10 is 220. Which of the following must be true on the interval 0 to 10? We did this in AB as well. G of 0 is 20. And that's 0, and this is 10. Right? G of 10 is 220. Now, this is just one possible graph that I'm drawing. There's infinitely many possible graphs. Which of the following must be true in the interval 0? G prime t is equal to 0. This is G for some interval in t. So this was just increasing. G prime t is equal to 0. What does G prime t means? G prime t means it's a slope. So let's find the slope here. G of 20 minus, G of 10 minus G of 0. What's the average gradient? G of 10
200
minus G of 0 divided by 10 minus
times 20.
10 minus 0. So that's 200 divided, this is a slope, right? 200 divided by 10, which is 20. And
So
the
we
slope
can
is given by
evaluate
the
AM.
f prime. This basically f prime t or g prime t. So g prime
Yeah,
t is
because
approximately 20.
It's exponential,
So
so
it's not
the derivative will
A.
be a linear.
Yeah, so the slope can't be 0 because you're getting a value
so
of
it's B.
slope which is 20. So just be g double prime t is equal to 0. Is there any inflection point here? Not necessarily. It may have an inflection point or it may not have an inflection point. So this is like, can g prime t be positive? In this case, I just drew a graph like this. I can have a graph which goes like this. So there's confusion there as well. There's counter examples. So you must try to think of counter example where you can disprove the statement. So that will become false. So this is concave down, this is concave up. So this is nonsense. G double prime
I see
equals
what you mean.
0. There is no inflection points here. So that's nonsense. G prime t equals 0. That's also nonsense because there is no, the derivative can't be 0 because this is either increasing function or it's increasing. It's only increasing. So it can only have positive slopes. Okay.
Mhm.
Makes sense. Right. Good.
Yeah.
makes
The
sense.
explanation is important. Yeah. You must always try to give counter examples to disprove the statement. You mustn't only think about a single graph that you drew, okay? Because that can be deceptive. Right, let's look at this. 6x squared minus 4x minus 25 over x minus 2. Obviously, the numerator is bigger, so we're going to do synthetic division. So put 6 minus 4 minus 25, put a 2 outside. Bring down the 6. 2 times 6 is 12. Add it up, you get 8. 2 times 8 is 16. Add it up, you get negative 9. Do you get negative 9? Yes, we do. That's a remainder, and that's a quotient. So this integral basically becomes, what's the quotient? 6x plus 8.
Plus 8 minus
Plus-
9 over x minus
Yes.
2.
Minus 9 over x minus 2. Easy peasy. This is just polynomial function, so that's just 6x squared over 2 plus 8x, correct? And this is minus 9 ln x minus 2 times 1 over 1, the slope, plus c. So no need to write 1 over 1. I'm just writing it down so you don't forget.
Easy.
Is answer A? Good. It's not easy, it was. It just looks complicated. Let's look. Which of the following statement about the convergence of the series is true? Now, the convergence of the series, we need to look at this thing over here, right? And what we're comparing to. Think about ln n plus 1, right? I want you to think about the ln n plus 1. Which function is bigger? Now, I'm going to compare it with n. Which one is bigger? Is n bigger or ln n plus 1 bigger?
No, n is
And
big.
N is bigger, so facing that way. Good. Now, if I flip this, it becomes 1 over ln. I'm trying to use a comparison. Because everything talks about a comparison. So that becomes greater than. Because when you flip a fraction, becomes, if you flip a fraction, right? So I'm comparing this with 1 over n. Okay. Now for large n, values, see what happens. Isn't this in harmonic?
Yeah, it's harmonic, P series, yeah.
Harmonic, so it diverges.
At P equal to 1, yes.
So what are you comparing it with? You're comparing it with 1 over n. So it diverges, can't be converges.
So C.
Yes, correct. Because this thing you must try to use some kind of comparison. So I need to compare it. So how did I know I needed to compare with the n? Because I'm looking at these forms over here. I said, okay, ln n plus 1. And let's see which one is bigger. Then flip it, and then you get 1 over n. You need to try to put these functions inside here. Yeah. The length of the curve from 0 to 3 pi by 4 is given by. What is the length of the curve? Length of the curve is equal to integral a to b.
A to b, yeah.
Square root 1 plus y prime. Wait, y prime squared dx. What's a to b? 0 to 3 pi by 4.
Yes.
Square root 1 plus y. What's y prime x?
Cosine squared.
What's the
negative cosine.
Cosine, yes. Cosine squared x. So what's the answer?
D.
The D1.
Yeah, D. That's what it's
Easy peasy, okay.
So just arc length formula, yeah. Let f be a function such that f prime x is equal to this. What are the first 3 non-zero terms of the Maclaurin series for f? Very important. You remember the expansion for sine x?
Yes.
Sigma negative 1 x to the power odd 2n plus 1 over odd factorial.
So it becomes x plus x minus.
No, it will start with x, good. Minus x cubed over 3 factorial plus x to the power 5 over 5 factorial plus dot dot dot. I don't care. They only wanted the first 3 non-zero terms. What is, so now what we want? We want sine x squared.
X squared.
So it will become x squared minus x to the power 6 over 3 factorial plus x to the power 10. We replace the x with x squared, okay? Makes sense. We only want the first three non-zero terms. What is sine x squared? That is f prime x. Makes sense. So what's f of x? Integrate.
The integral of it.
What's
So
the integral of x
negative
squared?
cosine x squared.
X
No, no, no,
cube
no,
over
no,
two.
whoa,
No?
whoa, whoa, whoa. You can't integrate something like this. There's a x squared there. You can't integrate something like that. You need to integrate these terms. That's why they said it's impossible to integrate this. You integrate these things. So it's x cubed over 3 minus x to the power 7 over 7 times what's 3 factorial? 6.
6. Nice.
All right. Plus x to the
And
power
x to the
11 over 11 times 120. 5 factorial is
Yeah,
120.
Yeah,
So what's the answer here now?
D.
It's
Mister,
D1, yeah. Large
Yeah.
Yeah,
numbers.
D,
Mister,
because
Large
11,
numbers.
yeah. 1320.
how can I not integrate
130.
sine x squared?
You can't. You don't have sine of x squared. Sine of x squared dx is a big problem because you're going to make u equal to x squared.
Okay.
Du is equal to 2x dx. You don't have x dx in
Yeah.
your integral, so it's impossible to integrate. You have to use numerical techniques to integrate that.
Yeah, it's a problem. We can't solve by substitution in that case.
Yeah. You don't have x dx in your integral. You're going to make it sine
Well, I'm
u.
thinking, wouldn't it be
What is
wouldn't
dx?
it be negative cosine x squared over x squared? No.
It's going to become very confusing. It's impossible. You have to use numerical integration. That's the reason why we use Taylor and Maclaurin series, because there are functions that you can't integrate. Are we good?
Yeah, but Mister, I have another
What do you
question,
think?
please.
What do you think is the purpose of Taylor and Maclaurin series? It's
To
because there are
integrate.
functions that you can't integrate. Yeah.
Yeah.
We use it for integrals and solving problems and for approximation, because it's not
Yeah.
possible to integrate sine x squared.
But Mister,
That's why
one
they
more
asked you
question.
for the first. Yes.
Why would they tell us f of 0 is equal to 0? How is that important in any way?
Okay. F of 0 is
In the
equal to
Maclaurin
0.
series,
Oh
it
yeah,
became
for the value of c. No,
for the
no,
value of C, yeah.
because that is plus c. We forgot the integration constant. Okay. So
Okay.
now if you put 0, you're gonna get 0. So c is basically equal to 0.
I see.
And by the way, finding just P3 here, you're just finding the polynomial up to the third term.
Mm.
Right, let's move on. All right, so what we have here, the polar curves r equals 1 minus cos theta and r equals 1 plus cos theta are shown in the figure above. Which of the following expression gives the total area of the shaded regions? Now, these are cardioids, okay? And that's also a cardioid. They just flipped, okay? Now, this side of the equation is this part here. Okay. And the other side of the equation, so which equation is that? The one that I have highlighted. This is 1 minus cos theta. Okay. And we have, let's see. What is this line over here? This is a pi by 2 line. And this is the 0 line. Are we good?
Yeah.
And this is obviously 2 pi line. Well, the 0 line is on the other side. Okay. Huh?
So Mister, this will be a is equal to 1/2 integral from.
Wait. Area is equal to 1/2 integral. Look, you don't even need the other side of the cardioid, but is equal to 1/2 integral of r squared.
From 0 to pi over 2, yeah?
No, from where to where?
Alpha,
What are the
alpha.
endpoints?
From 0 to pi by 2.
Yeah, from 0
Because
to pi
because
by
of
2.
this symmetry. R squared d theta, because r squared is a function in theta, right? Now wait.
No,
Let's
so we
see.
do
We
r
can just
out
take one.
minus r inner.
That's correct. Just a second, guys. Just try to figure this problem. I'll be 1 minute. Right, guys, so let's try to solve this. All right, so see, for the first part, we're just going to integrate. If you try to integrate, remember these are symmetries here. So you got 1, 2, 3, 4. They're all symmetrical. Okay. Because they are all symmetrical, just focus on one piece of the what you call one piece of this graph here, and we can just multiply it by 4. We don't need R out minus R in. We use that when we have different types of graphs. For now, because of the symmetry, we'll just use from 0 to pi by 2. Okay, this is 0 line, 0 to pi by 2. I'm just going to integrate this piece from 0 to pi by 2. You can see that piece there. I shaded it now. There's it. And this is a prime. This is 4 times. So 0 to pi by 2 of 1 minus cos theta. So you're going to have area is equal to half 0 to pi by 2. What we said, 1 minus cos theta.
Yeah.
All squared d theta. And there's 4 of these, right? 1, 2, 3, 4.
Yeah.
Times 4. So what's your answer here?
So C.
Do we have an answer? Yep.
Yeah.
Be good.
Mister, I was thinking, why wasn't it R squared out minus R inner squared?
Right, so if you're going to try to do that, you're going to use this. First, we're going to equate both the graphs. 1 minus cos theta equals 1 plus cos theta. We cancel out. First, we find the points of intersection. Right. So if you try to find the points of intersection, what we get here is 2 cos theta is equal to 0. Are we good? So cos theta is equal to 0. When is cos theta equal to 0? So cos graph is 0 at pi by 2 and 3 pi by 2. Or theta equals 3 pi by 2. So your area can also be represented as now the thing is, which one is inside, which one is outside?
We don't know. This is a problem, no?
Yeah, we can take either one because they are identical. So let's see. So you can say half integral pi by 2, but we don't have anything of this form. 3 pi by 2. R in minus out. It doesn't matter which one you choose, right? So we're going to take in minus out from here. So now we're integrating over this boundary. No. We can do this. I want you to put this on the calculator and give me an answer here. And I want you to put this on the calculator and give me the answer. So in both cases, so it's going to be 1 minus cos theta all squared minus. So this is your R in minus R out. So 1 minus cos theta squared minus 1 plus cos theta all squared d theta. So I want you to check this out and give me an answer. And I want you to do this and give me an answer quickly on the calculator. Because we're trying to get some theory here. This is because of symmetry. I just took one portion multiplied by 4. Okay, guys, you can check it up and just put a comment there. Let's move on. Right. The table above gives the values of continuous function f, selected values of x. If f has exactly 2 critical points in the open interval 10 to 14, which of the following must be? So this was done in AB as well. I think it was the same question number. I just want to draw and redo the graph again. So I'm going to put some values here. So what are the x values? 10, 11, 12, 13, 14. Then we got 2, 3, 4, 5, and 6. So what's the value at 10? It is 5. This is just one possible graph that I'm drawing. There are infinite possible graphs that you can draw. Okay. So do not get carried away with this graph because I'm going to look at counter examples to disprove the statements like what I said before. All right, so this is 10. 10 is 5, right? The value is 5. 11 is 2. So 12 is 3. 13 is 6, right up, and 14 is 5. So I'm just doing one possible graph. Right. Now, look at the f of x is positive for all x in the open interval 10 to 14. Is f of x
No.
positive?
No.
Because wait, where's the counterexample? Counterexample is I can go down.
Yeah, that's
Right.
10 to 11.
Yeah, so it can be positive or negative, so that's out. F prime exists for all x in the open interval. They're saying it exists, it can have corners, right? Because the graph can come down. I just drew a smooth curve. I could have drew a, remember at the corners, I could have drew a graph like this. Now it's not differentiable at the corner. All right, so that is out. So this option is out, right? Now moving on to the next one.
This one is also out.
Next one, f prime x is less than 0. Nonsense. You can get, you can draw a counterexample. We can do a counterexample here as well. You can come down between 10 and 11 and go up. You can go positive and negative, right? So it can't be negative only, it can be positive as well. Okay, because we don't know what's happening between 10 and 5. They said it's a continuous function. All right, so that's out. F prime 12 is not 0. F prime 12 is not 0 because we can take the slope between 11 and 12 and 2 and 3, isn't? Or we can take the slope
Yes, you
between
can.
those two. We can take the slope between those two and see that f prime 12, we can approximate the slope is either positive or, yeah. So it's
D.
definitely, it does have a slope, so D is correct. Must be true. It's definitely not 0. It does have a slope.
Okay, let's move on. So yeah,
Why
pretty
is it
easy.
C?
Yeah, so
Before
no, the graph, okay, you have a question, it can't be C because look at the yellow graph. If you're looking at the yellow graph, what's happening there is between 10 and 11, right? You can have a decreasing and an increase. That's the reason why it can't be C. And what it says, f prime x less than 0 means it's decreasing only. That's nonsense. I give you a counter example, alternative graphs that you can get. Always try to use counter example. Let's look at this question here. Let g be a function such that g of y is positive. Very important. G of y is positive. When will you get something that's always positive? Maybe x squared, right? For all y. G is always positive. So maybe x squared plus 1. No, y squared plus 1, isn't? For any y value, this is always positive. Does that make sense?
Okay.
What does it say? Let g be a function so that g of y is positive for all y. It means that for any y value, this is always positive. Now, I just guessed a function here. Now I'm going to compare this. This is my entire function now. Now I'm going to compare this at two different values, maybe 0, 0. And I'll choose another point, -1, -1. So what's the slope here? At 0, 0, if I substitute 0 here and 0 there, I will get a negative slope, right? Correct? I'll get -1. I substituted x value 0 and y. Hey guys, you remember how to do this thing? I'm trying to check the first one, option A. If I substitute 0 here and 0 there, -1 times 1 is -1. So I'm getting a negative slope. What does option B tells us? The slopes are positive, so this option B is out. Correct? And option C is also out because the slopes are like alternating positive and negative at 0, 0. Okay, at 0, 0. Now I took a specific point. Okay. What if I choose other values of y? What if I choose 0 and 2? X value 0, y value 2. What's the slope? If I choose x value 0 and y value 2, I'll still get negative slope, isn't? So I will get -5. So let's see. Is the slope negative at 2? 2 is higher up, right? Somewhere around there. Yeah, the slope is still negative. Yeah, the slope is negative, but the slope here is positive. So that option was out. See over here, if I go higher up, this slope is turning from negative to positive. So that's out. Option C is out. Right? Now we're stuck between options A and option D. Okay? Are we good, guys?
Yeah, let's see, sir. Just a second.
Yeah.
Right, so now let's substitute -1, -1. Maybe -1 and -1 is somewhere around here, okay? If I substitute -1 inside here, I'm getting 1 minus 1, which is 0. Right, so M is just 0. So the slope needs to be flat. This was decreasing and that was decreasing slope. Obviously more slope here. Right, so this is flat and I can see it is flat. Let me take this dot out. Can you see the slope is flat at -1? Oh, wait, 1 second. -1 and -1 will be around here. Coming down, yeah. Can you see the slope is flat? And it doesn't matter which x value of -1 I take, -1 and -2. If I substitute -1 and -2 here, the slope will still be 0. Because -1 squared minus 1 is 0. 0 times g of y is 0. So it doesn't matter which point. So it looks like it's option A. Let's look at option D we are confused with. Let's go to -1. See what's happening with here. It's not 0. It's not 0. See, those are not slopes 0. It has a negative slope. So all that is wrong. So only option A works. Okay. So try to fit in a function that you like. So option A
So I don't
correlates
understand.
with everything.
How is C incorrect? Because C has flat slopes as well.
Let's go to C.
But not all
C is
slopes.
no. I rejected C over here at 2. Remember, I chose a point 0 and 2. I was supposed to get a negative answer, -5. But now at 0 and 2, it has a positive slope. See there. I
Oh, yeah, I
rejected
see what you
C
mean.
at that point. Yeah.
And
So
same
that
with
was my
B.
yeah. Why did I reject B? I rejected B at 0 because of the negative slope at the first point. 0, 0.
Yeah.
Suppose you get negative. I got a positive slope at 0, 0. So that's why. So just choose points and substitute, you get the answer. Now, what are the values of P for which? I say improper integral. We don't need to integrate this. What are the values of P for which this here converges? Now, remember, this is your AN, okay? What is this? This is like 1 over AN.
Yeah.
AN, P, let's just say, yeah, just say this is your AN function. Because this is like your terms of your series. Now, let's look at 1 over x to the power A. When will this converge?
When it's greater than 1.
Good. When it's less than 1, it will diverge. Right. So when A is greater than 1, it will converge. P series, okay?
Yeah.
Now, what is the value of A? 3P plus 1. 3P plus 1. So 3P is greater than 0. P is greater than 0. Easy peasy, man. Come on, see. Okay? Makes sense? You don't need to integrate. We're just talking about yeah. You said when A is greater than 1 converges. I'm comparing this x to the power A with x to the power 3P plus 1. What
Oh,
is
it's
A?
not D because it also can be P is greater than 0. Yeah, I understand. Yeah, because 1 also can be an answer because 3 times 1 is 4, so it also can be converged. Yeah,
I'm just comparing it. I'm just comparing with the convergence of the P series. That's it. Why stress? You don't need to integrate this. Next one. The temperature of a solid at time t greater than equal to 0 is modeled by the non-constant function h and increases according to the differential equation. So we got a differential equation, all right? Where h of t is measured in degrees Fahrenheit and t is measured in hours. Which of the following must be true? So we need to solve this differential equation, okay? So we're going to say dh, bring the 2h plus 1 at the bottom, is equal to dt. Now integrate both sides. Integrate. You know what the integral of this is. You get it wrong. What's missing here? times
2 times 2.
times 1
Slope
over
of the-
2.
No,
1
1
over
over 2
n.
divided by 2. Yeah, yeah.
1 over 2, yes. Equals, what's
Oh,
the
divided
integral
by
of
2.
1
Yeah,
dt?
1 over 2.
What's the integral of 1 dt? T plus a constant. Now, which one is the answer? You're going to multiply both sides by 2. So you're going to get ln absolute value 2h plus 1 is
So
equal
B.
to 2t plus another
Oh, no, sorry.
constant. Make it constant 1
D, yeah.
and make this another constant.
so
2
D.
times constant is just another constant. Good. T. Careful how you're solving this problem. Last one. If the power series a and x minus 4 to the power n converges at x is equal to 7 and diverges at x is equal to 9, which of the following must be true? Now, when is the power series convergent? By the ratio test, remember, we end up with x minus c. What's
Yeah.
the value of
Oh,
c
yeah.
here? 4. X minus c is less than r. Isn't that a radius of convergence?
Yeah.
For the ratio test
And
is
x,
an plus 1 divided by an, yeah?
yeah. And when this is greater than r, it is
Diverges.
divergence. Right, very good. Now let's look at this. What's the value of c here? 4. So at x is equal to 7, what's happening? We have 7 minus 4. So you're going to say absolute of 7 minus 4. No, they're telling you it converges at x is equal to 7. So is less than x, absolute value of 7 minus 4 is equal to 3, which is less than r. Are we good?
Oh, I see what you mean. Yeah.
So what is this?
So R must be
But
4.
it converges. You can choose r to be 4. Good. No, what you mean r must be 4? Yeah.
No, because if it was
Oh,
9,
yeah.
so 9 minus 5, 5 is greater than that. Yeah.
So that converges. At x is equal to 9, 9 minus 4 is 5. But now they're telling
Yes.
us that at x is
It
equal to 9,
diverges.
it
So it's greater
diverges.
than R.
Right. Now let's see. The series converges at x is equal to 1. Let's check. X is equal to 1. We have 1 minus 4, which is 3. X is equal to 2. 2 minus 4, which is equals to 2.
2.
And x is equal to negative 1, which is negative
5.
1 minus 4, which is equals to
Positive
5.
Oh, yeah,
Now-
5. Yeah.
Now, remember when you found this, you said the convergence is basically the radius is between minus 3,
3,
now 3, and 5.
3, yeah. And
The
5.
interval for the radius of convergence is between 3 and 5. I think this one can be included. So what you said is 4 is probably correct. You can choose 4, right? Now, remember these things over here, these values, the 3 and the 5 lies on the boundary of the radius of convergence, lies on the boundary. Lies on the boundary. Okay, so it may converge or it may diverge. And this one here also lies on the boundary. So it may converge or diverge. Okay, so those two things here, wait 1 second. So what did they say in x equals 1? The series converges at x is equal to 1. So because it
Yes, it
lies on the
does.
boundary, no, wait. Because it lies on the boundary, it may converge or diverge. Remember, this is a definite statement. They told you this already. You can't use this for this, right? Because we don't have an. An can be like an alternating series. It can be negative 1 to the power n. So At x is equal to 1, it can diverge or converge because it lies on the boundary. See, it's equal to 3. That one is equal to 5. Both of them
Oh.
lies on the boundary. So if
And
it lies on the
3 is the
boundary, it
same
can
thing.
converge or diverge. Yeah, so this one and this one out. So the only option is this.
So
Two
B.
only.
Option number 2. 2 only.
Oh, I
Right.
thought it was because when x is equal to 7, it gave us the same answer, so it must converge.
Use a calculator. So obviously we can solve these questions much more faster. But you don't need a graphing calculator because you have Desmos. And now let's start solving these problems. Right, so let's see. Question 76. The graph of the function f is shown in the figure above. Which of the following statements must be false? All right, so which one must be false? Limit as x approaches 2 from the left of f of x is 3. Is it approaching 3, 2 from the left? 2 from the left is going to, is exactly 3. So it's more like f of 3, right? Limit as x approaches 2 from the right is 2 from the right is positive infinity, okay? Must be false. That's a 2 from the left. 2 from the left is 3, is correct. 2 from the right is infinity. Yep, correct. It's true. Limit as x approaches infinity of f of x is 0. Oh, limit as x approaches 2 of f of x equals f of 2. Now, this is a continuous function. It means there's no break-in point in the graph. This is continuous. Now, is this function continuous? No, because we have a broken point here. You see? See, this point is broken between 2 and that point there. So there is a break-in point in the graph. So it's not continuous. It's not one smooth curve, right? So this is false. So if you figured out the false one, what about limit as x approaches infinity? Is limit as x approaches infinity 0? So infinity is somewhere around here. Yes, and it's approaching 0. It's true. So C is false. Let's move on to the next one. Question 77. The rate at which the water leaks from the tanks in gallons per hour is modeled by R. So R is already a rate. I think we did this in AB as well. A differentiable function of the number of hours after the leak is discovered. Which of the following is the best interpretation of R prime T? So R prime T will basically become like how fast is the water flowing out. So it's like acceleration of this water flow out, right? It's leak. So how fast? So basically it should be per hour, right? Leak, first 3 hours after the leak, the amount of water in gallons that has leaked
So
out
D.
of the tank. Yes, yes. The rate of change of the rate of water leaks out from the tank in gallons per hour is more like acceleration. Remember what I said? Think about acceleration. Because this is more like velocity, right? Let's continue. On a certain day, the temperature in degrees Fahrenheit in a small town T hours after midnight, T equals 0, is modeled by the function 65 minus a sine pi over T. What is the average temperature in the town between 3 a.m. and 6 a.m. in degrees Fahrenheit? Average temperature is average value of function. So average is equal to 1 over 6 minus 3 integral 3 to 6 of g of t dt. Right. Do this on your calculator quickly. Give me the answer.
Give me a second.
G of t dt, you need to make sure your calculator is on radians because you're dealing with sine. Make sure radians mode. Yeah, always keep your calculator on radians mode. Integral
57.797. I got it.
Perfect. Excellent. Right, and make sure when you're typing it in now, when you're typing this, make sure this part is in brackets for g of t. Because when you open an integral, make sure you put it in brackets. Now let's move on to the next one. Let y equals f of x be a solution to the differential equation with initial condition f of 1 is equal to 5, right? Selected values of f prime x are given in the table above. What is approximation of f of 2 using Euler's method of step size 0.5 starting at x is equal to 1? Euler's method is yk plus 1 equals yk plus h times
f function.
dy dx evaluated at xk yk. Now, the nice thing about this is there is no yk because you don't need to evaluate. It's not a function in two variables, just a function in a single variable. So we're going to write down x naught, x1, x2. So x naught is, what's the initial point here? Starting at x is equal to 1. So x naught is actually x1. And then we are using step size 2 to find f of 2. So if you start at 1, so what's your step size? H is equal to 2 minus 1. You're finding f of 2. 2 minus
given.
1 divided by 2, which no, it's half. Oh yeah,
It's
they
given
give us.
0.5.
Yeah, H is 0.5. So I also found it for you. Sometimes it's not given. So there's it here. So the next point will be 1.5 if you're starting at 1.
1 plus 0.5, yeah. 1.5.
Yeah, and then the next one will be 2, and that's the value we want. So what's y naught? Y naught is basically evaluate. Remember, this is evaluated at x equals 1, x equals 1.5, right? And x equals 2. So those are your values. Yeah, so basically it's already written there, right? So your initial condition is this 1. What's y naught? What's f of 1?
0.5.
No. What's y naught?
Or oh, 5.
They tell us is 5. Yeah. The f of 1 is 5. Yeah, so that's 5, right? So we need to find y1 using Euler's formula and y2 using Euler's formula. We get these answers. Right, so let's say what's y1? Y1 is approximately equal to, y1 is basically f of 1.5, which is approximately equals to 5. What's yk? Y naught, the previous value. 5 plus, what's the height? What's the h? H is half, 0.5.
Yeah.
And what's dy dx evaluated at x naught, y naught? Evaluated at 1, x naught, which is 1 and 5. Is f prime x. So you need to evaluate this at 1 and 5. So x value of 1 will give us 0.5. Yes. Makes sense.
Yeah. We don't include 5. Yeah.
Yeah. So
Only
because
X
we
values.
so x value of 1 gives us the derivative. Derivative is dy dx. So which is 0.5. So we put 0.5 here. So now 0.5 half times half is quarter. So that will give us 5.25. So put 5.25 here. Right. Next one. So what's y2? That's f of 2, right? Which is equals to y2 is f of 2, right?
5.25 plus
5.25 plus 0.5.
0.5 times
The previous
evaluated
value.
at
The previous value.
1.5. So it's 0.4.
Perfect. And now what's half of 0.4? 0.2.
0.2, I think. Yeah.
So 5.45. So 5.45. Yeah.
0.2. 0.2. Yeah.
0.2 plus
basically.
5.25. So 5.45. Right. I didn't even need a calculator for this. Let's move on to the next problem. The first derivative of the function is given by this on this interval. On which of the following intervals is the graph of f concave up? It means where this is the first derivative. Concave up means on which intervals is the graph of f concave up. F concave up means f double prime x is greater than
0.
which means that we need to look for increase on this function where f prime
So we
x
take
is
derivative.
increasing. No need to take derivative. You have Desmos, put it into Desmos and see where the graph is increasing.
Oh,
okay?
Yeah. No need for that. Yeah.
So we got f of x. Let's call it g of x, all right? Is equal to x to the power 2 plus 1. What's the function? Sine 3x minus 1. Sine 3x minus 1. Right, now I need to change the settings here to negative 1.5 to 1.5, negative 1.5 to 1.5.
Can you zoom?
Yeah. No need to zoom out. We're just looking for the increase on this graph. Just looking for the increase.
So it's negative 1.5 to negative 1 and 0.5 to 1.
Wait. We're looking for the increase. Increase on the derivative function. So looking for the increase on the derivative function is increasing here. Look here, from there to there. So that point should be somewhere around there. Okay. So it's increasing there. Right? That's the small piece is increasing. Where else is increasing? So it starts to increase from here as well. Say that point there, and this entire thing right up to that point. Okay. So it can't be negative 1.5. It's not, yeah, it's increasing from negative 1.5 to negative 1.341. Is that negative 1.341? Approximately, yes. And negative 0.24. Yes, negative 0.24 is about 0.25, 0.24. So 0.96. Yep. I'll go with option A. That's the only one that makes sense. Because it's decreasing here. From 0.964 to 1.5 is decreasing there. So you can't take that. We're looking for concave up. Negative 0.714 is somewhere around there's a decrease there. Nah, not this. I'll go with the option 1. Are we good? The
Yes,
pieces
easy,
were
sir.
highlighted.
Yeah.
Right, easy. So no need to differentiate and stuff. You can go straight into.
Exactly, yeah, just Desmos, yeah, that's it.
Perfect. For t greater than or equal to 0, the velocity of the particle moving along the x-axis is given by this function here. At what time t does the direction of the motion of the particle change from right to left? Again, Desmos. Because we need to check velocity positive, v of t greater than 0 is up, and v of t less than 0 is down. Right, so it's going to become negative, so it's going to change direction at that point. Okay. For t greater than 0, we're looking in the first quadrant. So t cubed minus 6t squared. Let me just make it x to the power 3 minus 6x squared plus 10t minus 4 plus 10x minus 4.
You don't need for changing x's.
Yeah, you're only looking at the x-intercepts. So where is it changing direction on the x-intercept? Between when it's more than 0. It's changing direction at 0.5. It went from negative to positive, and then it went from positive to negative. So from right to
it's
left.
not at 0.5, no? Just
No,
sorry.
we want from right to left. So let's take positive as right and take negative as left. So 2. At 0.5 is moving from left to right. We want from right to left, from positive to negative.
Oh,
Okay.
that makes sense, yeah.
So the answer is C. And at maybe 3, just before 3.5 is moving from left to right again. 82, let f be the function such that f of 1 is equal to -2, f of 5 is equal to 7. Which of the following condition ensures that f of c is equal to 0 for some c in the open interval? This is a conditions theorem, right? There are 3 conditions, right? So it's definitely not that one. Open interval, we're looking for something that's closed interval. F is continuous on the closed interval. Yes. Okay. And it's differentiable on the open interval 1 and 5. such that f of c is equal to 0. I think it's intermediate value theorem. Okay, so it's a theoretical question. It is C. Are we good?
Sorry, sir. Again. Sorry, Mr.
Look. F of 1 is equal to -2. So 1 is -2. F of 5 is 7. So you're looking for a point in between this. The function has to be continuous on 1 and 5. And it needs to be differential. Yeah, not necessarily increase. In this case, increasing, yes, because you're looking for this point C. Okay, f of c is equal to 0. This point C is between 1 and 5. So it needs to be differentiable on 1 and 5, and it needs to be continuous on 1 and 5. It has to be like a curve. It doesn't have to be like this. It can be like that. It can be like that. You can draw infinitely many curves in between, right? So it's one of the theorems that we learn: mean value theorem, Rolle's theorem, and intermediate value theorem. So this is IVT.
But what does mean the definite for all values of x? So we know all the value of x, or what?
No, you can have a graph that is broken. Okay, in the interval 1 to 5 is defined for all values of x. No, we're not talking about defined values, and we're talking about continuous functions. The function has to be continuous. It's just a theorem. There's theorem with 3 conditions, and you can't change this condition. Okay. Right. For t positive, the position of an object moving in the xy plane is given by the parametric equation.
So is that
what is this? Yes, welcome.
sorry?
What is the position?
No, just one second.
fine.
Can you go back to the 82?
Yeah.
So when it says f of c is equal to 0, what would that tell us?
It tells us there's a root in the interval 1 and 5.
So it must be continuous if it says f of c is equal to 0.
Yes.
Okay, I see.
Because at the point C, you can have a broken graph. But then it won't be defined for values of x in the interval.
Yeah.
It has to be continuous, right? What is the speed of the object at time t equals to 1? Now, speed is this here. Speed is equal to square root of
Prime square, yeah.
X prime squared plus y prime squared evaluated at t equals 1. So how will you do it on the calculator? One step you can do it. So you're going to say ddx of, change this to x function, x cos x over 2. No need to differentiate, at t equals 1 plus, how are you going to square this? You put another bracket and square it. Man, this is, okay, that's what you got to do. You have to put a bracket and square it, and put another bracket ddx if you don't want to differentiate this, right?
Yeah, just a second.
The square root of x squared plus 2x evaluated at t is equal to 1, right? And square this. I suggest find this answer and find this answer first, and then square root of a squared plus b squared. Let me show you how to do the storage. Watch here.
Yeah, I'm doing
Let me
it.
show you.
I got you how to do.
You know how to do it, right? So I'm going to say shift ddx. Shift ddx of, what's the function? Alpha x cos, open bracket. Yeah, it opened a bracket for me. Alpha x over 2. Wait, my calculator is not in radians mode. Shift mode, radians 4. Right, evaluated at 1. Right, so I've got an answer of 0.63. I'm going to store this in A. So shift store A. You might not have it, so you need to write out the full answer. So I got this in A. Shift ddx, right? And I'm finding the second function, square root of alpha x squared plus 2 alpha x. And that's going to be evaluated at 1. Right. Shift store B. I stored that answer in B. I'm going to say square root of alpha A squared plus alpha B squared. Look here, guys. If you're using calculator, put the full answer down, square it, put the full answer down, square it. You don't have to do it like this. And I've got 1.319. Exact answer, B. Nice, easy. We're good, guys.
Yeah.
Right, next question. What was 83, 84?
But Mister, if I wanted to delete A or B, I can just replace it by taking another answer and putting it in.
Yeah. Right, so question number 84 now. The graph of the function g is shown if f is a function given by f g of x. What is the value of f prime 0? Easy peasy. Find the derivative. What's f prime? Is g prime g of x times the derivative of the inside. G prime x. That's it. So what's f prime 0? F prime 0 is g prime. What's g of 0? G of 0 is 3. And what's g prime 0? Now, what is g prime 0? Now, very important. What functions are these? Linear functions, right? What does g prime 3 represent? The slope at 3. So what's the slope of this line? You need to find
rise
it.
over run.
Yeah, rise over run. So you can maybe just go here, man. Rise over run for here.
5 plus 1. Yeah, 5 plus
no,
1.
No need. I got 2 over 1. 2. Is it here?
Yes, so 2.
So g prime 3 is just 2 times. What's g prime 0? Whoa, hold on. G prime 3 is not 0. G prime, we just found g prime 0, which is 2. What we found here is rise over run. This is 2. And g prime 3 where's 3? 3 is on the downward slope.
Well, it's a negative slope, yeah.
Yeah, so this is negative slope. I don't know how you're going to do the slope here, but you can do it anyhow. Let's see. Just drop down this vertical line here at 1. You're going 5 up, 5 across. So negative 1. So what's the answer? Negative 1 times 2. Negative 2. How's that? Easy.
Again explain, sorry. G prime 3.
Press. What's g prime 3? 3 is here. 3 is here. It's on the downward sloping lines. So what does g prime x represent? The slope function. Now, because it's linear, the slope function is constant. Whether you find g prime 3 or g prime 4 or g prime 5, it's just going to be constant. And it's constant and it's negative. I'm just doing rise over run. Okay. So you can find the slope over here, slope of this line from negative 1 to 5. So the first slope at 0, I can say 5 minus 1. So 5 plus 1 over 1 minus 1 plus 2, which is 2.
3, yeah.
So the second slope is downward sloping. So it is 5 minus 0. 5 minus 0 over 6 minus 1. No, 1 minus 6, which is negative 1. So at 3, the slope is negative 1. And at 0, the slope is 2. So you just multiply g prime 3 times g prime 0, which is negative 2. Okay?
Okay.
Easy. Next question. Let f be the function defined by f of negative x equals negative f of x. Give me an example of what function is this? F of negative x equals negative f of x. No. What function? Okay, sine function. It's an odd function.
Odd
so you
function,
can take
odd.
So you can take a sine function which is odd. So this is a sine function. What happens if I evaluate the sine function from negative a to a or negative pi to pi? Isn't the areas will cancel out?
Yes, they will.
If I take integral from negative a to a of f of x, where this function is odd, the answer will just be 0. The net area will be 0. So what are we trying to evaluate here? We're trying to evaluate this function. So negative 2 to 2 of f of x dx plus negative 2 to 2 of 6 dx. I just split this because function is in two parts, isn't it? You're allowed to take the integral into sums. What is this? This is odd function and it's negative a
So
to
zero.
a. So this answer is 0. Good. This is 6x evaluated from -2 to 2. So 6 into, put 2 here, you get 2. Minus 2 is +2. What's the answer? 24.
24,
6 times 4.
nice.
Yeah, that's it. Easy. 86. I think we did it in this as well. AB. This was done in AB. Yeah. So you know what's happening. So this is the top graph minus the bottom graph, right? Let's see. Let R be the region in the first quadrant bounded by the graphs of y equals 4 cos pi x over 4 and y equals x minus 2 all squared. So x minus 2 all squared is this quadratic function over here. See, it's turning through 4 and -2, right? So this is a quadratic function. So this is the bottom function, right? And this is the top function, 4 cos pi x over 4. Now, as shown in the figure, the region R is the base of the solid. Each cross-section perpendicular to the x-axis is an isosceles triangle. Isosceles triangle here. With a leg in region R. So there's a leg in region R. So this is a leg, the vertical leg. And so obviously you have two legs in the isosceles triangle. Right. The two legs are equal. So what's the area of this cross section? Half base times height. Half leg squared. What is leg? Leg is the top function, y top minus y bottom. What's the top function? Top function is 4 cos pi x over 4. Right? And the bottom function is x minus 2 all squared, right? Are we good? And squared there.
Yeah.
Okay.
Anyway, to find the volume, you just integrate this cross-sectional area. Integrate all of this. Do it quickly. Integral of this whole thing. Put the half outside the integral. And we're integrating from, we're integrating from
1/2
0 to 2. Half base times height. There's a base, leg, and the height is leg. So leg times leg is leg squared. It is half base times height. Half base is the leg.
No, but isn't that just for a half
The
triangle?
base is the leg. Yeah, but they said it's perpendicular to the x-axis, so you draw a perpendicular sign here, and it's an isosceles triangle. Isosceles triangles are two legs are equal. So it's leg times leg. So that's why you got leg squared there. Right, so integrate this from
top over bottom, that's it, sir.
Yeah, top minus bottom.
1.77.
That's your leg.
I got 1.77, sir.
1.775. That's correct.
77.45.
775, that's correct. Suppose limit as n approaches infinity of a of n. Suppose, yeah, a of n is infinity. A n plus 1 is greater than a n for n greater than equal to 1. Which one of the following statement must be true? So this here, when we substitute infinite, what does this here mean? If a n plus 1 is greater than n, what does that mean?
Is it a ratio? No, wait.
No, not ratio. It means that it is decreasing.
No. Oh, decreasing.
Decreasing.
Yeah.
Decreasing.
So alternative signs.
You can have alternating signs, or you may not have. We need to check each one. This here means is decreasing, all right? 1 second. No, sorry, 1 second. 1 second. This here does not mean decreasing. It means a n plus 1 is greater. So this is the condition that it must satisfy. These are the conditions for the series. So everything starting from 1, so you don't need to worry about this because everything starts from 1. All right. Now, does 1 over a n diverge? So let's check. A n is infinity, so 1 over infinity is 0, correct?
0. Yes.
So that basically converges. It does not diverge. One second. One over an is equal to, okay. So an over here, you see, limit as n approaches infinity of an. It's not negative infinity, it's positive infinity. So an has to be positive. Okay. That's one thing to note. An must be positive. We don't have a function for an. That's a problem here. Okay, we can provide counterexamples. Okay, let's provide counterexamples like how we usually do it. Right, so let's provide counterexample. So yeah, so this definitely means that an must be positive. So let's provide counterexample for an. So if an is equal to 1 over n squared, does this converge or diverge?
That will diverge. Oh no, converge.
Converge
P-series,
because it's
isn't
P
it?
series. Yeah. This will converge.
Yeah.
So this is incorrect. What about this one? If I provide something for an, let's just say an is 1. I can choose any value. They said an is positive. An, no, I can't choose 1 now. Let's just say an is equal to n. Okay. So what's happening here now? One is you can get positive and negative values. What if an? Okay, what we said an is positive, so I can choose a value of an to be 1 as well. It's fine. But isn't this here diverges? Because it's negative 1. I just made an equal to 1. So if you take out an, then you can get oscillating. So the answer is if n is equal to 1 is negative 1, right? If n is equal to, then it's positive 1, isn't it? And it just oscillates between negative 1 and positive 1, negative 1 and positive 1, correct? So it's
Yeah.
divergent because you're getting two different values. You're either getting negative 1 or positive 1. So this is also out because this diverges. Not necessary. I'm providing counter examples, okay? 1 over an converges. 1 over an converges. What about this one now? What's a counter example we can provide for this? 1 over an converges. We can say an is equal to n. So you got sigma 1 over n. What can you say about that?
It's diverges. No, wait, yeah, because by the P-series, isn't it?
Yeah. So this is p equals 1. So it diverges. Now remember, it's very important to note that harmonic series usually diverges, but an alternating harmonic series converges. So we can choose an to be equal to n here as well. An is equal to n here, and we say this here converges because it's alternating. Converges, alternating. Remember this, very important. Alternating harmonic series, right? Always converge. Is very handy to remember. Okay. So we'll go with D. Are we good?
Okay.
Because I've provided counted examples to prove this. All right, next example. At time t positive, a particle moving in the xy plane has velocity vector. If the particle at the point 1.5 at time t equals 0, how far is the particle from the origin at time t? How far is the particle? We want distance, right?
Distance? Yes, yeah.
Yeah, we want distance. Right, so let's check. How are we going to solve this? So first, we're going to solve. Okay, this is a velocity vector, right? Velocity vector t is equal to 3 and velocity vector v is basically x prime t and y prime t, correct?
Yeah.
That represents x prime and that represents y prime. So how are we going to solve this?
So we need the arc length.
Wait, yeah, we need the, yeah, that will be the final point. So first we need to find, right, so basically we need to find the distance, which is square root of x of 1 squared, but we need to find x of 1 first,
Well,
right?
prime.
By
No, it's
no,
prime,
no, no,
right?
not prime, not prime. We're finding distance. This is the primes. We need to integrate these functions.
Teacher,
And y of,
it should be absolute
second.
value in that case.
yeah, you're squaring here. You're squaring here. So you should be fine. Watch out, watch out. Look. So what we need to do is, remember, this is the velocity in the direction of x. So we're on the position, right? And we need the position here. So we know x prime t is equal to 3. Okay? So x of t is equal to,
3x.
let me just say, wait, one second. Let me say x of t minus x of 0, fundamental theorem of calculus. X of t minus x of, is it x of 0? No, they started at the point 1. At the time t equals 1, x of t minus, no, yeah, x of 0 is fine. Yeah, at time t equals 0, how far is a particle from the origin at time t equals 1? X of 0 is equal to 0 to t of 0 to t of x prime t dt. So now we want to find x of t function, right? You have to find x of t function, so you can substitute 1 inside. What is x of 0? What's x of 0?
So we don't know.
X of 0, x naught is 1. Yeah, there's it here. It's 1.
Yeah, one.
If the
Yeah.
particle
times
is,
it's 0.
yeah. X of 0, you're going to move x of 0 to the other side is 1 plus, what's x prime t? X prime t is 3. So it's going to become 3t, right? That's it. 3t evaluated from 0 to t. So that's it. Done. 3t. Okay? Makes sense.
Yeah.
Yeah, makes sense.
Now, y prime t is equal to 2 to the power negative t squared. So y of t minus y of 0 is equal to integral 0 to t of 2 to the power negative t squared dt. So now you're going to have, man, we could have just found x of 1 here. What's x of 1? Remember they said from 0 to 1, we can just get the value. Why are we doing this? You can have just found 0 to 1 of 3. So we want to find x of 1. Remember, the ultimate goal is to find this. So x of 1 is now equals to 4. Right, so we got 4 squared, which is 16. That's sorted. Now, remember, the value of t is 1 here. So you say, what's y of 0? Y of 0
1/2.
is half, yes. So y of, let me put y of 1 here now. So it's 1/2 plus 0 to 1 of 2 to the power negative t squared dt. Now I can't find this integral. You got to use your calculator for this. And give me
Is it
the
negative
entire
4
answer.
t?
No,
to the
I need the
t
answer.
squared?
It's going to be a positive answer.
No?
It's going to be a, no. You can't integrate this. Because if you make this equal to u, you'll have no t to cancel it out with. The derivative of t squared does not appear in the integral. Right, I want this answer here was y of 1/2 plus 0 to 1 of 2 to the power negative t squared
It's
dt.
0.4.
No,
Oh,
I
no,
want the
wait,
exact answer.
wait,
I
no,
want
no,
the full desk.
no, wait.
It's
It's
0.5 plus
it's 1.31.
0 to 1 of 2 to the power, oops,
No, sir. Yeah.
2 to the power negative alpha x squared 1.31. 1.31, okay? Because I added the half as well. Now, I've got this here, so distance will be square root of 4 squared plus 1.31 squared. Square root 4 squared plus answer squared. I'm getting 4.209. Okay? Right, great. Let f be the function f of naught equals 1, f prime 0 equals 2, f double prime 0 equals negative 2. Which of the following could be the graph of the second degree Taylor polynomial? What's the second degree Taylor polynomial? The nth degree, the full Taylor polynomial is f of x is equal to sigma, the nth derivative evaluated as c over n factorial,
n factorial.
x minus c to the power n equals 0 to infinity. Expand to 2 terms only. So second degree polar Taylor polynomial, the value of c is 0. The value of c is 0.
Oh.
So the first one, the 0th derivative evaluated as c over 0 factorial x minus 0 to the power 0 is just 1 plus n is 1. So f prime 0 over 1 factorial x minus 0, so x to the power n. Double derivative evaluated as 0 over 2 factorial x squared. That's all. So you got 1 plus what's f prime 0? 2. 2x. Did I write x to the power 1 here? This should be x to the power 1. That's x to the power 2. That's x to the power 0. So 2x. What's f double prime 0? F double prime 0 is negative 2. Negative 2 over 2 factorial is negative 1. So negative x squared. So what's the function? Negative x squared plus 2x plus 1. So which graph can it be? It has to be, it can't be a straight line. It can't be positive quadratic because that's concave up. It can either be A or B. Now we need to check. Where's the turning point? How you find turning point? Minus B over 2A, the vertex. Minus B over 2A, or the derivative equal to 0. Minus B over 2A is minus 2 over 2 times negative 1, which is 1. So the function is turning at 1. Okay? So it can't be here because this function is turning at maybe 0.25, quarter. So it can only be answer B. Are we good? Hello?
Okay, yeah, nice.
Make sense? Last question. The series negative 1 to the power n plus 1 converges to a s based on the alternating series error bound. Alternating series error bound. What is the least number of terms in the series that must be summed to guarantee a partial sum that is within 0.03 of s? So basically within the error of 0.03. How are we going to solve this? So what's the error bound? Error bound is basically the total sum, S infinity minus the total sum minus Sn, right, is less than Rn.
Or equal.
Did we use Rn?
Oh, yeah, or let's just listen.
Or what did we use? Is less than An plus 1. The sums that we left out. Remember, we're totaling the sum to infinity. We're starting at 0 and we're stopping there. So n plus 1 onwards, we are leaving out. So basically, you took the total sum minus this sum. So you're just left with this piece here. So I'm just taking one portion of that, the terms that are left out. All right. So now what we're saying is that an plus 1 is less than equal to, is within 0.03. Make sense?
Yeah.
Now, what we see here is that this series is decreasing because as you increase the denominator, it decreases. So we know that an is decreasing. Can you see this this an is decreasing because square root of n plus 1, n plus 2, n plus 3, right? Basically, it's saying it converges to s, so it's decreasing, right? If you take n approaching infinity inside here, limit
It will
as
take
n
0.
approaches infinity of an, you'll get 0. Good.
So it's
So we know
alternative
that.
sign.
So we know this here converges to s. So they already told us it converges to s. So there's nothing to do there. So what we can say is, what is an plus 1? Look at this. What is an? I'm going to leave out the alternating signs. We don't take alternating signs. It's more like absolute an. So I'm going to take as 1 over square root of n. So what's an plus 1? 1 over the
1
square
over
root.
root n plus 1.
Right. So now that is less than equal to 0.03. Problem solved. You're going to flip this denominator and you're going to flip this. So you're going to become greater than equal to 1 over 0.03. You get square root of n plus 1. Okay. Solve this, square both sides. N plus 1. I'm squaring both sides, guys. Okay. So I squared this side and I squared this side. Right. And I'm going to take this 1 over to the other side and minus, right? Oh, no, you don't need to do that. What's 1 over 0.03 all squared?
Just a second, sir. I was doing it.
Partial sum that is within 0.03 of s. So we just want an plus 1. So basically n plus 1 in this case. You can't take the 1 to the other side and subtract. Come on, man, that's
Oh.
easy. Just find this value of
Yeah, sorry,
this
I
one.
delayed everything. Oh.
It's 100 over 3. 1 divided by 0.03 is 1 divided by 3 over 100. So 100 over 3 squared.
So
Oh man,
one,
syntax
for
error.
1.111.1.
1111. 1111. Do we have an answer? Aha. Perfect.